Hello viewers and my dear students. Welcome to session 3 of problem 4 on analysis of beams. Here I will be giving you a demo on beam with inclined loads using Ansys Release 14 of Mechanical APDL mainly to obtain bending stress and deformation diagrams. As you know, this is session 3. In the first two sessions I have concentrated totally on bending moment diagram, shear force diagrams and reaction solutions and all that. Here I'll be concentrating on bending stress and deformation diagrams. Okay. Now you see here the problem is this. As you know, the problem is this. The problem is this. In this way, the beam is subjected to inclined loads as shown. Determine the following. Assume beam has a cross section. Same problem. 0.2 into 0.3 meters. E is 210 GPa. Poisson's ratio 0.27. Determine bending stress diagram and maximum bending stress using theoretical procedure. Use Ansys Mechanical APDL to verify the above answers. Deflection curve of the beam. Determine, that is, deflection curve of the beam and maximum deformation due to inclined loads applied. The distance moved by the roller due to the inclined loads applied also. See here, all other things are simple. This also I have asked. In fact, see here, this is a roller load, no? Because of the inclined loads and all that, this beam is going to bend. As a result, this is a roller, no? Here, the movement in x direction is allowed. The roller moves. Either it can move rightwards or leftwards. If it moves rightwards, it will be positive x. If it moves leftwards, it is negative x. Okay. Anyway, this distance, how much the roller moves, either leftwards or rightwards, due to the applied load, also has to be determined. That's what I have given. Okay. Now you see here, this bending stress diagram I have written here. Bending stress diagram theoretical procedure. See here, first I got bending moment diagram, what I got in the last session. This is 204.85, 259.64, here 173.15 at B, at A and E are the supports, they are 0. Okay, now the maximum bending moment is 259.64, correct? No? Maximum bending moment. That is why maximum bending stress will be M into Y by I. M maximum bending moment you take 259.64 Newton meter. Y is 0.3 by 2 because this depth by 2. Depth of the beam is 0.3, width is 0.2. Okay, 0.3 by 2. 0.2 into 0.3 cube by 12. If you do that, 86,546.6 Newton per meter square you get. That is at this stage. Okay. If you want if you want bending stress at this, same way. In place of 259.64, use apply 204.85 here. Do the same calculations. You get 68,283.3. And if you want bending stress at this point, what do you do? In place of 259, you substitute 173.15 here and do in the same way, you get 57,716.6 Newton per meter square. This is a bending stress diagram, what you can do theoretically. Okay, this anyway we'll prove it using answers. See here, I have got everything now. I have created a new log file. Nothing is there except for the title, subjected to inclined loads, bending stress diagram. This is what I just included. It's a fresh log file. Okay, I have created a fresh log file. Gurdat inclined loads, bending stress diagram. That is a new log file. Everything will be created in this. Okay, now you see here, I'll go in the same way. Preferences, structural you go, say okay. Then preprocessor, element type, add, edit, delete, add you go, beam 2 node 188 you take, just say okay and just say close. Okay, material properties you go, material models you go, structural, linear, elastic, isotropic you go, it is 210 GPa, E9 you apply, 210 E9, Newton per meter square. Okay, 210 into 10 to the power of 9 Newton per meter square. That means compulsorily you have to do the model everything in meter only. Then Poisson's ratio 0.27 also you take. Okay, just say okay and say material exit. Okay, once you do this, you go for sections, beam, common section, then 0.2 width and depth is 0.3 you take. Carefully, this is 0.2, this is 0.3, say okay. Okay, this be careful here, this is be careful. You do all this now. Now, once you do, go for modeling. Create key points in active coordinate system. As you know, it is a beam is 4 meters in length. Okay. Every 1 meter you have a load. Okay. In that way, create key points in active coordinate system. Okay. Okay. Key point 1 you say 0, 0, 0. Right now. Key point 1 is 0, 0, 0. You just say apply. Key point 2, you say 1, 0, 0. You say apply. Okay. Key point 3 is 2, 0, 0. Say apply. Key point 4, 3, 0, 0. You say apply. Key point 4, 5, 4, 0, 0. Say apply. Then key point 6, you say this 4 minus 1 you do, say okay. I'll just say 1, 2, 3, 4, 5, 6. The significance of this, as I told you, it is just for the beam to rotate by 90 degree because it would not have been aligned. That for orientation of the beam, this point is necessary, which I'll be explaining it to you later on. Okay, now this right now, don't worry, and you know very well, there is one point created. It can be any distance. This can be any distance, but you have to create one point here. It is now I have created -1. Okay, it can be -2 or -3, but just to fit in the screen, I have taken -1. Okay, now create lines, straight line you take, click on this, 2 to 3, 3 to 4, 4 to 5 you do. Just say okay. Okay, I created by lines. Now, you see here, meshing, be careful, meshing, mesh attributes, picked lines, you click this, you click this, click this, click this, okay, say okay, and pick orientation key point, compulsorily you click on this, okay, that is pick orientation, because I have to rotate the beam by 90 degree, that is why this has to be done. Pick orientation key point, yes you say, okay you say, click on this point 6, compulsorily click 6 here, and then say okay. Okay, then size controls you go, size controls, manual size, lines, picked lines, you click on all these 4 points and say okay. You can learn in the last problem I made 50-50, it was 200. Now let us say I'll make, just to make things simple, I'll make 10. 10 means totally 40 elements would have been created. You can make 25, 100 elements would have been created. In the last problem, same problem, 50-50-50-50, 200 elements are made. Just to simplify this, I'll just say 10 elements here. I'll just say okay. And as you see, 10, 10, 10, 10 have been created. Then mesh, lines, pick call you do. Okay, meshed lines pick call if you do, you are getting list. If you get list elements, you see here 40 elements would have been created. Correct now? Now it is perfect till this. It is 40 elements have been created here. It is all correct. Now you see here whether the beam has been oriented properly or not. We have taken up the procedure. Whether the beam has been oriented properly or not, we'll see. Style, size and shape, you see. Display elements, now we make it on. Say okay. Okay, say okay. And just say isometric view. You see here, perfectly it is. It is 0.2 here, 0.3 here, and the load will be applied on this surface. That is the top surface, load will be applied. Okay, and it will be proper. Okay, that means the orientation of the beam is proper. Now plot controls, style, size and shape. I'll just say off. I'll just say okay. Then plot elements. I'll just do this. Okay. Now you see here carefully. Now I'll do plot lines. Okay. Plot lines I'll do. Okay, now this is one line, 10 division, this is 10 division, this is 10 division, this is 10 division. Easy, I don't have to enlarge it and all that like the previous problem. Okay, now what I'll do now here is, see here, this, once you do, under modeling, you know, modeling, okay, nodes, rotate nodes by angles is there. Okay, see here, at this point you click, okay, say okay, this has to be rotated by minus 30. That means there is a load here, at 60 from vertical, no, this way is positive, this way is negative. From vertical, minus 30 means here it will be 60. The load will be at an angle of 60 degrees to the axis of the beam. Okay, minus 30 you do. I'll rotate the node by minus 30. I'll just say okay. Okay, this is done. In the same way, rotate node by angles. You see here, this also I'll do. Okay, I'll just say okay. Rotate node by minus 45 I do. I'll just say okay. Okay, then rotate node by angles. This is very important here. These things you should know. Then say okay. And this is minus 60 I'll do. Once I do by minus 60, I have rotated this. Okay, minus 60 means, from this minus 60 means the load will be applied at 30 degrees. Okay, 30 degrees it will be that. Okay, then you say okay. Okay, now everything is done. Now what I'll do is I'll go for application of the load. Okay, loads, define loads, apply, structural, displacements, on key points. You take this first, you take that key point, just say okay. Here UX, UY, UZ, rotation X, rotation Y, rotation Z you leave it off, you make it 0. Just say okay. Okay, then displacement on key points, you take this point carefully here, okay you do, but UX also should be there because it's a roller support, no? The movement in X direction also will be there. UX you make it open. That means you can see the movement in X direction. UY, UZ, rotation X, rotation Y and all that you make it 0. Okay, this also is over. Then if you come to this, okay, force on moment, now you see carefully, force on moment on nodes. Okay, see carefully, I'll take this node where I have rotated the nodes by already minus 30. That means the load should be at 60. I'll just say okay, Fy you make, okay, then you say minus 100 newtons. Minus 100 it is, correct, it is minus 100. You just say okay. Now it is, see here, it is perfectly, it is at 60 degrees, that inclined load is applied in the downward direction. In the same way, force moment on key points, I'll apply here also. Okay, I'll say Fy will be minus 200. Fy will be minus 200. Just say minus 200, correct, no? This is acting in the downward direction at 45 degrees. In the same way, force moment on nodes, you take this node and say okay, and Fy will be minus 300. Okay, this you have to be very careful. Now you see here, the loads have been applied properly. Okay, this is at 60 degree, minus 100. This is at 45 degree, minus 200. This is at 30 degree, minus 300 newtons. For this loading conditions and all that, we have to solve the problem and analyze, and you have to get the bending stress diagrams properly and deformation also properly. Now we have come to the end of session 3. In session 4, we'll complete this problem in all respect. Okay, thank you friends. Thank you for watching. Please look to session 4 on inclined loads bending. That is the continuation of this problem where we'll be completing the problem. Thank you very much. Thank you.